continuing our study of quadrilaterals in Chapter 6. We're going to actually do a lot of the converses of what we did in the previous section and use those properties to prove whether or not a quadrilateral is a parallelogram or not. So we're going to look at those properties and then examine quadrilaterals to see if they're going to be parallelograms. So opposite sides have to be congruent, opposite angles have to be congruent, opposite sides have to be parallel, diagonals bisect each other. So with that, we have a whole list of the converse theorems. So theorem 6.5, if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So if I can prove this to be true, where opposite sides are congruent, I prove that that quadrilateral is a parallelogram. Theorem 6.6, if both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So this is very similar to the previous section, except for instead of starting with parallelograms and then finding properties, we're starting properties and seeing if they become parallelograms. So in this case, if the opposite angles are congruent and both pairs are congruent, then we have a quadrilateral that is a parallelogram. Theorem 6.7, if the diagonals of a quadrilateral bisect each other, the quadrilateral is a parallelogram. Again, I take a quadrilateral, draw the diagonals. If the diagonals are bisected, both of them bisect each other, then we have a parallelogram. And then if one pair of opposite sides of a quadrilateral is both congruent and parallel, then the quadrilateral is a parallelogram. Now this is the one that's different, so I want to make sure you stand out. We'll actually prove this one, but if one pair of opposite sides of a quadrilateral is both congruent and parallel, then the quadrilateral is a parallelogram. So let's go ahead and actually prove that one right now, because that's a good one. If both sides of a if one pair of sides of a quadrilateral is parallel and congruent, so WX is parallel to YZ, and WX is congruent to YZ, we're going to prove this theorem right now by showing that WXYZ is indeed a parallelogram. So let's go ahead, do our 2-column, 1 WX is parallel to YZ, and WX is congruent to YZ. That's a given. Alright, let's go ahead and update our picture. Parallel, congruent, and let's see what we can find. I'm going to add a diagonal at XZ. Add segment XZ. There we go. And that's just by construction. And what that does, that gives me 2 triangles to work with. Well, if that's the case, I will call this one angle 1 and angle 2. Angle 1 and angle 2 are alternate interior by the diagram. And then, if they're alternate interior and we have parallel lines, then we know we have angle 1 is congruent to angle 2 by alternate interior angle congruence. So that gives me a side, which was given, an angle, and then also our construction, XZ is congruent to ZX by the reflexive property. So that actually gives me the other side. So I have a side, an angle, and a side. So I've got these triangles here that are congruent triangles. WXZ is going to be congruent to triangle WXZ, YZX. And that is by side angle side. But also observing that ZW and XY are corresponding from the diagram. But if they're corresponding and they're parts of congruent triangles, then ZW is congruent to XY by CPCTC. And then noticing from that, opposite sides are now congruent, and opposite sides are now congruent. So, what that shows us is that WXYZ is indeed a proper parallelogram. So WXYZ is a parallelogram by the properties of parallelograms. One of those properties is both pairs of opposite sides are congruent. We were given that one side, or one pair was already congruent. We proved that the other is congruent. So both pairs of opposite sides are congruent, which means it is a parallelogram. So again, a long proof, but it's not hard. You just have to kind of work through it. You'll see a lot of this kind of technique show up. Draw a diagonal, there's not one drawn. Show triangle congruence of some sort, find corresponding parts, and then work from there. It's kind of the theme that we use for most of this section. A lot of the proofs will have that same structure. So let's go ahead and actually apply some of these problems, or some of these theorems, on the practice number 2, 8, and 14. Go back and look at the proof that I did. Go back and look at the properties of parallelograms that prove a quadrilateral is a parallelogram, and good luck.